Hey PhysCalc, and welcome back to another U-Substitution example video. In this video, we're going to be talking specifically about what happens if we have division involved in our function. What happens if you have an embedded function that is part of a fraction, part of some division going on. Now, this might seem very specific, and it is, but division is something that we have been struggling with, not just as a class, but like all people tend to really struggle with division and fractions. So I figured it was worthwhile to do a quick example video just showing you what it looks like when we do division inside of our integration for U-substitution. So for our example, let's take a look at the integral of 12x to the 5th plus 3 divided by 2x to the 6th plus 3x plus 2, with all of that on the bottom taken to the 5th dx. Pretty long, lots going on, but U-substitution is going to be super helpful. Because remember, U-substitution is all about seeing if I can get my function into the form the integral of f of u du. Because if I can do that, I'll probably end up with a more straightforward function that I can then use to find the integral more easily using known rules. So there's a couple things going on here. I have a u thing and a du. So the first thing I want to do when I do the chain rule is figure out, are there two things in here related by a derivative? Is the derivative of something in here another thing that's in here? And the first thing that I'm noticing is that this function down here, this 2x to the 6th plus 3x plus 2, looks a lot like it might be a u for a couple of reasons. One, it has something being done to it. It's being taken to the 5th power on the bottom of my function. But we also have this 12x to the 5th plus 3 that looks like it might just be du, or related to du. Because if we take the derivative of my purple function, we can see that it is my green function. The derivative of 2x to the 6th is 12x to the 5th. The derivative of 3x is 3, and the derivative of 2 is 0. So I'm looking right now at ways that I might be able to set this up. So if my u is in fact equal to 2x to the 6th plus 3x plus 2, that would mean that my f of u, the thing I'm doing to u, is taking all of that to the 5th power. Or really, because it's on the bottom of my function, I'm taking it to the negative 5th power, because I'm doing 1 over that stuff to the 5th. So that's equal to 1 over u to the 5th. You can think of it either way. Both will get us where we need in the end. Now we need to take a look at what my du might be. And to find du, we need to start with du dx, because du dx is just the derivative with respect to x of u. And in this case, I know what u is because I just decided it. It's right here. So this is going to be d over dx of 2x to the 6th plus 3x plus 2. Taking the derivative of that, I find that it's just 12x to the 5th plus 3 plus 0. And that is equal to du dx. I can now rearrange this, take my dx and bump it over here, to see that du is equal to 12x to the 5th plus 3 dx. All right, well that's really helpful because I have a 12x to the 5th plus 3 over here, and I have a dx. So what I want to do now is I'm actually going to rewrite this function in a way that might make it a little bit easier to see if I really have all of my pieces together. So this is actually equal to the integral of 2x to the 6th plus 3x plus 2 to the negative 5 times 12x to the 5th plus 3 dx. So all I've done is taken this purple stuff, this 1 over u to the 5th, and I've moved it up to the top with a negative exponent because that makes it really clear to see that 12x to the 5th plus 3 dx is the same du I got down here. So that is definitely du. And this 2x to the 6th plus 3x plus 2 to the negative 5 is going to be f of u, which again is u to the minus 5th. Now that I've done all of that, it's not too hard to see that I can now rewrite this as the integral of f of u du, which, as we just said, is the integral of u to the negative 5th du. Now that I have that, I can solve the integral of u to the negative 5th pretty easily using my power rule. So remember, the power rule says that an integral of something to some power is equal to 1 over that power plus 1, so negative 5 plus 1 is negative 4, times the thing to the original power plus 1. So negative 5 plus 1 means u to the negative 4th. Last but certainly not least, I'm going to take a look at the fact that I have a u here and I want it to be an x. But lucky for me, right up here I already wrote u in terms of x and I'm all ready to go, meaning I can rewrite this as 1 over negative 4 times 2x to the 6th plus 3x plus 2 to the negative 4th power. And that is my answer. Now, if I really wanted to, I could clean this up, so I'll go ahead and show you what this looks like in a nice cleaned up fashion. So let's just take all of our du stuff and we'll move it out of the way for now to show you that if we wanted to make this look a little bit nicer, what I could do, because this is the minus 4 power, is leave the 1 on the top, and I'll go ahead and move the negative up there from the 4 on the bottom. So negative 1 over 4 times 2x to the 6th plus 3x plus 2 to the 4th. These two things are equivalent. They are exactly the same. One might look a little bit neater to you, but both are the right answer. Or at least they would be the right answer if I hadn't forgotten the eternally important and always forgotten plus c. So once I add my plus c's here, then these really truly are definitely the right answers. We can't forget those plus c's. Golly. And that is how we use U-substitution when we are dividing two things. You can think of it in a couple of different ways. The key step here, I would say, is this step right here, to identify our u and identify your f of u, remembering that when we have 1 over something, it's that thing to the negative 1 power, or the negative 5 power in this case. So that's our key step. If you remember that, you should be all good to go. Good luck, PhysCalc.